listeners, Harika here, and I'm super excited to welcome you to UppTalk. If you're ready to learn and get your hands work wonders in the world of information technology, then you're in the right place. When I say UppTalk, we are not just another edtech company. Consider we are your learning partner committed to unlocking your full potential. Whether you're stepping into the world of technology for the first time or looking to advance your career, we provide top-tier, hands-on courses to build up your career. Let's take our first step towards learning here and explore it.
These are the options available in the data foundation for inserting, and these are for detecting. The tool automatically provides some of the features to detect, like if you want some help from the tool, if you are not sure, like how which join is suitable and all. Then we can also select these options like detect join, detect cardinality, detect row count, that it will automatically detect which join would be suitable for the tables. But it is always recommended to give joins from ourselves. But whenever, if you have a doubt or something, then we can go for these options. Detect options where the tool automatically gives. To insert tables in the data foundation, first we will create a data foundation, then we'll select the insert table option. Like if you see here, this plus symbol is for insert. If we click on this arrow, we will see like what do you want to insert. Do you want to insert tables or insert derived table? Insert, join or insert view insert command. If you select on insert tables, we will get this option like select tables to insert. We already created a connection to some database. Data source. Whatever all the tables there in that connection in that data source will be appeared here. Based on our requirement, we can select the tables in this checkbox and then we can click on finish. Once we select all the required tables, that all the tables will be inserted in our data foundation. We also have option to insert derived table. Like if you want some logic to be performed between two tables, like if the required columns are there in two tables and if we want to achieve that logic in single table, we can create insert derived table and we need to write formula which we want to achieve. And then we can insert that derived table in the data foundation and we can use that table as a normal table and we can provide the required joins and we can use it as a normal. We use derived tables in the following situations. To create a table with columns from other tables. If we want a column from other tables, we can create a derived table and we can pull them using these formulas. To create a single table that combines two or more tables. If you want to combine two or more tables into a single table, that is called a merger table. In that situation also, we can create a derived table and insert it. To create a table that contains a selection of columns from different tables. In a multi-source enabled data foundation, if you want to include database-specific functions in the definition of the derived table, you must select database-specific syntax. If you want to achieve database, if you want to use database-specific function, we have to use that kind of. If we want to MySQL or that kind of database-specific syntax, we have to use. As you guys already gone through what are the joins, what are the types of joins, and what is the purpose of joins. This is already covered. We don't need to mention again here. In the joining when we insert tables, we will go for joins there. We will give like on basis of which column we will join. Mostly, we will use the primary key of the table. If you see here table 1, table 2, in the left hand side, it is a table 1 hand side, it is a table 2. We are joining table 1 with the table 2. The table 1 name is article lookup. Now, table 2 name is article lookup criteria. We are joining both these two tables using the primary key article ID. Article lookup. If you see here a formula, this is fashionpublic.article lookup. Article lookup.article ID is equal to article lookup criteria. Article ID. If you select these two things, the formula will automatically come here. Then we will validate here if this is correct or not. If the join is validated, it will say it is. Then we will set up the cardinality. Is it a 1 to n or n to 1? That means for one article ID in this article lookup, there are n article IDs in article lookup criteria. That is kind of 1 to n join. Whether it is n to 1 or 1 to n, the tool will automatically detect here. If you click on detect, it will come up whether it should be 1 to n or n to 1. That is about cardinality and join. Once we validate it, we click on that, the join between article lookup and article lookup criteria will be formed. In this case, in this way, same method we have to follow for all the tables to join. Here join operator between table 1 and table 2 expression. This is the expression. It will automatically be displayed when we select the columns here. Cardinality is a property of join that describes how many rows in one table match rows in other table. That is a kind of like for one article ID, there will be n rows, like there will be many rows which will match with that article ID article lookup criteria. In that situation, it is set up the cardinality. We can automatically click on this detect and it will come automatically. Here, these are the cardinalities for a join 1 to 1. If it is a matching with only one row here, one row and one row only there, then it is 1 to 1. 1 to many, many to 1 means n to 1. Many to many means n to n. In our data foundation, sometimes there will be chances of occurring loops and traps. Loop is like this. If our joins are forming in this kind of scenario, if you see here, from country table to resort to service line to service, service to invoice line to back to sales customer city region, and it is again joining with the country table. It is like a closed path. It is like a closed loop is formed. In these situations, we will get a problem with the data. A common type of join problem that return too few rows. We will not get expected rows of data, but we will get less number of rows if there are any loops formed. Loops occur when joins form multiple paths between lookup tables. A loop is a set of joins that defines a closed path through a set of tables in a schema. If it occurs in this situation, we have to resolve the loop by creating an alias of one table. We can create aliases. The loops can be detected by detecting aliases, detecting contexts, detecting loops, checking integrity or visual analysis of schema. We can just by seeing the schema, we can see like there is a loop formed. Or if the schema is too big and if you're not able to understand, if you click on detect aliases, detect context or detect loops, then it will show like one loop is formed. That kind of thing will be there. And checking integrity is also, or if you check on integrity also, it will display like there is a loop formed between these two tables. We can resolve loops by two methods, by creating an alias table or by creating a context. A context is like we will set. Context is a collection of joins which provide a valid query path. We will set up like this path should be followed like that. We will set up, that is a context. Alias is like we can create alias of one table in the loop. For example here, customer table, we can create alias of a customer table, and for one path we can use that alias table, and for this path we can use the original table. That loop problem will be solved. These are the parameters. As I told you earlier, like parameter is like a variable in the universe that requires value at a query time. It is useful to prompt the user to supply a value. If you are only interested to know the data about region of Asia, and we don't want other regions' data in one universal, one report, then we can set up that as a region, as a parameter. And it will, whenever we use that report, it will ask the user like it will ask at the time of generating report itself. It will ask which region you want to go for. Then he can give the region as Asia. Then that Asia data will only come into the report, that the performance of report will be better, as we are not interested in other region. The data will be less and the performance will be better. List of values is again, we told you like if for ER object we can provide the list of values for around 30 years where we perform the analysis that is given along with the object. That whenever user selects that prompt, he can select from the given list of values instead of he himself entering the ER value. He can select from the given values. These are the data foundation properties like description. Summary allow Cartesian products, multiple SQL statement for each context. This is useful to resolve context SQL parameters. These are some properties. These are all properties that we can see in the screen. These are kind of traps, chasm traps. There are two types of traps that get formed sometimes in our universe. If too many to one join tables converge on a single dimension table, here from orders and from loans, there are too many to one joins converging on a single table. In these situations, if we need the data from orders table and also from the loan table, in that situation we'll get wrong results because of the chasm trap. To avoid that trap, we can, as here we have this option, multiple SQL statement for each context. If we click on this, we can resolve that chasm trap context problem. It will not here. As I told you already, that can be resolved by defining context. We will be a context 1 and context 2. We will define the context. This customer to order table will be one context, that is one path, and customer to loan will be other path. We will define two contexts and we will check this option to multiple SQL statement for each context that problem will be solved. Now we will create a data foundation. Once we connect this connection, we will just click on new data foundation and we'll say single source and we'll give the name demo. I gave the name like this. Once we connect this, it will automatically appear. As we already connected to MS Access database, the tables which are there in those database are appearing here. Once we get that, here is the insert option. As I told you already, there are options for insert tables, insert derived alias, join views, and all. We are going to insert tables. If we click on this, we will see what are all the list of article, lookup criteria article, color lookup, calendar, year outlet lookup, product, promotion, fax promotion, lookup shop fax, calendar year lookup. These are all the tables that are there in the database. We can select whatever all the required tables. We will select all these tables article color lookup. As I already selected these two tables, It is shown with green tick mark. We do not need to click again. If you click again, there will be an alias table formed. We do not need it now. We will click the tables which we require for our analysis. We will also keep these aggregated tables. I'll let you know what is this aggregated tables later. I have selected the required tables and I'm clicking on Finish. Yes, for the tables, the requirement will let you. You will know from the requirement the tables you need to select. The project team, they will give all the information in an XLR kind of thing, like what are all that? What is the data source? That configuration, everything will be done from there. They will give the table names and also they will provide the join between the tables, like on which, like I will tell you here, article ID is they will provide the joins along with the tables that we can follow that document and we can create a universe. We do not need. The architect will provide that information because we are not sure, like from functional side, which is correct for what. Architects will provide the document. Developers will do that. Thank you. For example, if you see there are two types of tables in any schema. One is a fact table. A fact table contains all the key figures like sales, revenue, quantity, all the number which are very interesting. I mean important for the business. Here, if you see here, amount sold, quantity sold, margin, these are the key figures. If you see here, 1 to 1 to 1 to means it is, these are the numbers. Fact tables are the tables which store number related data or KPIs or measures. We say measures for these kind of objects, margin amount and quantity revenue, everything is a measure here. Article, product name, state, country, the text data is we call as a dimension table. A fact table stores the measures and the primary keys of all other dimension tables. Please remember it fact table stores all the measures and the primary keys of all the dimension tables, whereas the dimension tables they store the information about that particular dimension. If you see here promotion, it will store the information related to that promotion. ID promotion flag. If you see here calendar table, it contains the dimensions related to calendar, week, month, year, outlet. It is a store related data. Shop name, address manager. Those kind of data will be there in these dimension tables, whereas this fact table stores the measures and the primary keys of all other tables, like the foreign keys. We can say, if we take this shop fact table, we will put in this middle. Always we will try to keep the fact table in the middle and the dimension tables in the sides. Just for our visibility purpose, because these fact table will be joining with all other dimension tables, it is better to keep in a middle. I'm putting it in middle. This is article lookup. First, what we have done is we have created a data foundation, connection data foundation, and we have inserted the tables as of now. After that, and we are setting the tables like we will keep the fact table in between and all other dimension tables in the sides. This is the fact table which is important. This is also one kind of fact table here, product promotion facts. This is the main fact table. First, we will join out outlet lookup. Outlet lookup table. After inserting the tables, we will join the tables with the primary IDs. They will only provide the primary keys. I'll let you know, like here shop ID is the primary key of this outlet lookup. Shop by shop ID, only the data will be uniquely distinguished. All of the shop name and all might be same, but shop ID will be unique in this table. Shop. The fact table also stores the primary keys of other dimension tables. Here there will be shop ID here also. What we need to do is click on this shop ID and just put here this shop ID and double click on this. Sometimes if you wrongly put, also we can again select here. If this is a shop name is selected also, we can check here from outlet lookup shop ID to shop facts table shop ID. We can click like this. Left table shop ID and table shop ID. We will just validate it whether it is correct or not. This formula, see we just selected here automatically the expression already formed. We will validate it. It said it is saying that expression is valid. The expression was successfully validated. The cardinality, we don't need to give us a 1 to enter into 1. We don't need to think about it. We can just click on detect. It will automatically come up. 1 to end, the relation is 1 to end. We will click on. Previously, when we did not put the cardinality, we went. When we did not click on that, it will. The question mark came. Once we put that and we validated it, the question mark has gone now. This join is proper now. There we formed, we created. Join between these two tables. In the similar way, we will create the joins with the other tables also. Now we will go for article lookup table. The article ID is the primary key of this article lookup table. Fact table will also store the primary keys of other dimension tables apart from the measures. Where is article ID? We can just see, or we can just put somewhere. We can drag like this also. If you see, here also it comes like a color code. We can put like here also, but here we can change article. Lookup of article ID, shop facts also. We should join with the same primary key. Article, and we will validate here. This is where successfully validated. We will detect it. We will put this. And now we will go with the article color lookup. This table. We will put it here. We can put it anywhere just for our understanding purpose. I am dragging. You can click on it. You can put this anywhere, but to show it in a neat format, I am keeping like this article color lookup here. Also, article ID is a primary key here. Here we will join with the two tables, like they have given 1 second. So, we will just put like this and we will double click on it. And now we will write the formula like it should match with the article ID here and article ID and also color. We will just click on control and we will select color code also in both the places. It is like a complex join like article color lookup dot article ID, sharp facts dot article ID and article color lookup dot color code and sharp facts dot color code. We will detect it here. 1, we will validate whether it is correct or not. It is valid. Here, if you see this too, as we are using two columns, the kind of join is looking different. It is. Now we will go with the product promotion facts table. Here also we will go use article ID only. Article ID here, article ID here. We will detect it. It will come as 1 to 1. Validate it, it is valid. Mostly in our projects, we don't create a universe from the scratch, but it is good to know like where we do what, and that is for understanding purpose. I am trying to explain you. Here it is a universe. Maybe it is one kind of modeling that we are doing in business objects everywhere. If it is AP Hennen or SAP Believer, they also do some kind of modeling using joins and all. The UI might be different, but the process that they do is very similar here. If we know one tool modeling, it is more or less similar. Basics are important. That's the reason I am explaining like in detail, but don't worry about like if you're not clear. Also, don't worry because we will not do it as a daily job. We will create reports as a daily job. This universe enhancement is very rare. You don't need to worry about it. Shop fact. I'm just putting it here, everything in detail, that when we are creating reports, it should not be like we should understand what we are doing. That's the reason I am to use the reports to create a report. We are using those objects. After doing all this hard work, only we are able to create or use those objects. That thing we should understand and we should know. To know the importance of all this modeling, I am trying to explain here. Product promotion facts is over. Shop facts. Week ID to calendar year. Week ID here to use the calendar objects like year, month and all. We will join with the week ID here. Week ID from both the tables. We will validate it and we will detect it. Click on. And product promotion facts. Here also there is a week ID we will join. These joins will be given by the business or architect itself. We should not need to worry about it. Promotion lookup promotion. Product promotion facts. Here the promotion ID is the primary key. Here is also promotion ID in the product promotion fact. This is one more fact table as I already told you. Article lookup criteria. Article ID, article lookup, article ID. Here article ID and the criteria article ID. See, you can see the question mark here. If you are not keeping the cardinality, if you are not detecting, the question mark is coming. Click on this, the question mark will go away. This is about the join. These are the aggregated tables that are topic I'll explain later. What are these aggregated tables? In this way, like we will select the required tables. And we will create joins and will put the cardinalities. It is about data foundation. Now what we can do is we can check integrity. We will just to check whether what we did is or not, or if there is any schema issue. Then here there is option like check integrity. Here we can check whatever we want to check. Tables, joins parameters. We did not create it. You can check like that and check integrity. It will come up like there is a loop got formed. It is saying we can avoid that loop by creating context or by creating an alias. Where is the loop? We can click Insert Alias Table. Maybe we can disjoin. We can give to vk to this alias table and we will remove this. How is we checking integrity? Now everything is. That is the way to resolve. We can just click on the table where the loop is getting formed. We can insert alias table. It will automatically give some other name. We can split the join as there is a loop getting formed between product, promotion, shop facts, calendar. These three tables are joined with each other and there is a loop formed. What we do is calendar table is joined with product table. We can create alias of this and only for the calendar table. Instead of joining with this product table, we can join with the alias. There will be the same kind of objects will be there in this also. We can avoid like that. That is about alias. We understood how the loop is formed and how we can resolve it. That is about loops and all. I'll just show you like what is this. This is about our data foundation. These aggregated tables, there is some concept beyond it. When aggregated tables are like these tables are aggregated to per year, per quarter, per month, like that they aggregated. Or if you want to get the if in our report, if you want to see the sales revenue of 2018 year, it is combination of all the months. Instead of giving it for all the months and then summing it up in the report level. If we use the aggregated tables and if we use these things in the formulas to go for the first priority, then what it do is first it will get, if our report is yearly based, it will get the result from this table that the calculations, instead of doing from the reporting layer, the calculations are being done in here, database layer, that the performance of the reports will be better. For that purpose only we use this aggregated tables and we use that in the formulas. I'll show you here like already existing measures. If I show you the formula, you will understand. If you see here, this is the formula for the sales revenue. What they did is, at the rate aggregate away sum of aggregate year quantity. This is one table. This is the other table which is set for the monthly level. Otherwise, it is normal shop facts table. First priority is given to this table. If we are only using for yearly data, but if that data will come from this table. If we are using for per day, if we are in report, we are also adding month and date. Then getting results from these tables will not be sufficient. At that time, it will come from the normal fact table. In this way, if we write the formula, it will take the benefit of this aggregate aware function that the result is coming from the aggregation. The sum is happening at the database level, which will improve the performance of the report and which will be helpful to not to load the reporting server. In that scenario, we will create the key figures like this at the rate aggregate aware, and we will use this formula, which is a default one. This for this also. You can, for more understanding, you can Google it, but it is the same concept, like to use that aggregated tables in our reporting layer. We will use this at the rate aggregate aware function, and we will keep the priority like first. Priority will be given to this table. Second priority is this. Last priority is this. Based on our report, it will go on, fetch the values. For all these things, for quantity sold also. This is the formula of quantity sold. If you see here also we are using that at the rate aggregate aware. We can take from this or we can use the normal fact table. Quantity sold. It is about at the rate aggregate aware. After creating our data foundation layer, we will go and create a business layer. Business layer is like this. Here, like we will put some classes. If you see, here I can go and new attribute. I can put something. I'll put here name just for demo purpose. It need not to be attribute. It can be a dimension. Here it is telling what is the type of measure is. As I already told you, you should be familiar with these terms. Dimension is like a text object, text objects which has a text data like state, calendar, year, month. These are come under dimensions. Measure is a number data, numerical data like sales revenue, quantity, margin, profit, discount. These all come under measure. Your name is a dimension. I just put as a dimension and I can go here. Year is coming from the calendar table. Calendar year. I can just put like this year, calendar year. Look, if I double click on it, it will come. All validated. Like that, we can create these objects. It is all ready. These formulas are also will be given by the architects. We will be having some demo to understand and we can create. But most of the scenarios, we will not go and create entire universe. In my 10 years of experience, I did not create any universe from the scratch, but it is better to have an understanding. If there is any enhancement required, we can directly go and do that. If there is any table need to be replaced, if we need to replace the table, always remember like if there is, if any, it is like a tip. Or if any project, if there is a requirement to replace some outlet lookup table, why do we get this scenario? Like maybe they are the project people or the database people. They are replacing the old tables with a new table because of some redundancy or something. In that situation, they will ask us to replace the table with a new table. In that scenario, what we have to do is, generally what we do is we will delete this table and we will insert that new table and we will have to map the joins. But that is not a best practice because if we delete the table, the objects which are related, which are associated with the table, they will be the formula. And also the joins, they will be gone. Instead of directly deleting the table, if you need to replace the other table, what you can do is you can create. You can do it. You can go and rename the table with the new table. You can create an alias that you can just go and rename the table then. We can do like this, also replaced by derived table, alias table, database table. We can replace in this way also. I think in the universe designer there was. I mean all the tools I told you, you did it. There it was option like the rename, but I think here it is more advanced, like we can replace by some other table. We can just click on replace by and we put database table and we can connect the table that the joins and its associated objects will not get disturbed, that there will not be much of rework. In our projects, we will get those kinds of requirements only to add any object in the business layer. With some, they will only provide formulas. We can just go and click on the adding the objects there and we will click on the formula and we can add that and we can export to repository or we can replace the tables or we can change the joins. These kinds of enhancements only will come, but in real time we will not get that requirement of creating a universe from the scratch because these days we are mostly working on HANA views or other databases or other data sources. Other, if it is a Bayes query, we do not even need to create this much of data foundation, all these things. We will just create a BSC connection and we are done. We can directly use that in our reporting layer. I think basic understanding of universe is that knowledge will be enough for our projects and the reporting purpose. This is done now. We have created a data foundation layer by using the required, by inserting the required tables, by proposing the required joins, by detecting the cardinalities. And the loop is also formed. And we have resolved that loop also by using an alias table. That is done. If you see here resolving loops, we can create an alias table or we can create a context. Parameters and list of values we have already discussed. Showing and profiling values in a table. This is show table values. We also have option to show table values just to see like what kind of data is stored in that. Calculated column is a new column in a table that is the result of a calculation based on one or more columns of the same table. Like it is like a formula we will create. Row. It gives the number of rows in a database tables and can be detected and stored in the data foundation. Merging tables lets you insert a derived table into the data foundation that consists of the combined columns from two or more tables linked by joins. It is like we will create a table using 2 or 3 tables. We will create one table. In that scenario, we will merge it. But that requirement is it is not very often. These are the some properties, preferences options like how, where are, what are the options available, like custom data foundation view, highlight related table. If you click on highlight related table, it will highlight. These are some properties and preferences. Chasm trap we already covered. We have created a data foundation. This is the demands. Once we create a connection, it is automatically kings. When we publish that connection to repository, the extension will beckons. That means secured connection. Text means this data foundation layer is saved as X. And the business layer. If you see here the already created universe, it is bugs. That is about the naming convention, how it automatically creates. And I was telling about this. Under data foundation, I have told you these insert options will be here. Detect options are here, detect alias, detect joins, cardinalities, raw, count keys. And if you want to arrange the tables, if you don't want to arrange it manually, we can arrange by clicking on this auto arrange tables. It will arrange tables for us. These are some options available in this. And we can also save you as image. Maybe we can save this as an image. These are the options here, aliases and contexts. If we put any alias tables, it will show up here like as we have created one alias to resolve the loop. Alias tables, here it comes up like this. Data foundation. If you just directly jump to data foundation, we can click on this and we can go there. Parameters and list of values. If we create anything, it will come under here. If you attach any object to the, I think I can show it for the already created universe. Parameters and list of values. It's not there. They are not using. If there are any attachments, are there that can be seen here. If we quickly want to jump, we can jump using these options to data foundation or connection and all. That is about data foundation layer. Today we have covered data foundation. Please do like, share and subscribe to our channel. For more information, contact us sales@upptalk.com.